There we go.
We made the thick machine, and we call ourselves ABC Corp, and our target consumer was moving companies. And our problem statement was that moving companies waste lots of energy and manpower hauling heavy objects upstairs. And what our design statement was that the design will increase the efficiency for moving companies and increase the time and effort needed to move more heavy objects. And project was boxed at 2 weeks. And force must be provided by some human input. Must lift at 12 inches. Must have 3 gears. And must be lifted in less than 30 seconds. Must have a minimum M of 3, and then must be under 3 mil. And then must have a way to measure with the force meter. And then for our decision matrix, we had 3 designs, and then the design that Blane made was the inclined plane compound gear. We figured that one was the best one.
Thank you.
Well, so we'll go back to the sketches.
Yeah, I know that's good.
So this was kind of my idea. We had a gear at the bottom, which you would turn, and then that would pull a string for the pulley to pull it up. Over here we have planes, which is the one we kind of took over, where we have the compound gear up top with the string pulling the weight up the inclined plane. And then Aydan has
He had something similar, just like a drop right here, pretty much.
Yeah. So this is our machine overall, our picture. As a total, it's 2.53 million, which is kind of pricey, but it's nice and durable there.
Yeah.
So we'll start with the string, where when you pull the string, it'll turn those gears, which then will pull another string to pull the weight up the inclined plane. It's a video.
Alright, so for the EMA of the inclined plane, we measured it out, and the distance effort ended up being 20.5 inches, and the distance resistance was 13. So to get the IMA, we got 20.5 divided by 13 to get 1.58. And then as for our compound gear, our driver was 3060, and it was directly connected to a larger gear of 84. So to find that, we divided 84 by 36 to get 2.33. And then, as you can see, kind of from the sketch kind of thing I tried to make, we did that twice, so we just multiplied those together to get 5.44. And then for the overall EMA, we multiplied both of those to get 8.6. For our effort force, we got 2.35. Resistance force was 9.81. So to get the EMA, we had 9.81 divided by 2.35 to equal 4.17. And then overall, we ended up getting an efficiency of 48.5%.
Okay, you go back to your little sketch there on the last slide.
Yeah.
I like that. That's really good. So you have the 36 teeth moving the 84 teeth, right?
Yeah.
So you did 84 over 36, so that's one IMA, right, from gear to gear.
Yeah.
But then that gear, that's a compound gear, right? So that big gear is turning that smaller gears right on it, right?
Yeah.
So that's a wheel and axle.
Oh, okay.
So you could do the diameter of that big one over the diameter of that small one, and that'd be another IMA.
Oh.
Does that make sense?
Yeah.
Then you would do the small one to the big one, and that's what you said was the same as the other one, right?
Yeah.
That's why you took it times 2.
Yeah.
That's why I didn't quite understand that. Okay, so really the only thing you're missing there is it should be even better because that wheel and axle there in the middle would be an extra IMA you could have put in there.
Okay.
So, but I like the sketch. That's great.
Yeah. Yes.
And then
That was it. Yeah.
Alright, in action, this kind of So
There we go.
these each are 12 inches, right?
What do you say?
Are these ones 12 inches?
Oh, yeah.
So yeah, so these
Right,
are 12
yeah.
inches, so that was kind of like our guideline to get
Make sure it was over the
where
top.
it was.
Yeah, that's good. All right, that's really nice, good.